What is going to be the limit as this function approaches -2? Well, the first strategy we can employ is direct substitution, where because we're looking at what happens as x approaches -2, what happens when x is equal to -2? So this means anywhere we see an x, we just plug in -2 and see if we get a valid number. Well, the problem we encounter is going to be in the denominator. When we plug in x is equal to -2, the denominator becomes -2 plus 2, which is equal to 0, which means that we end up dividing by 0, which you cannot do in math. So direct substitution won't work immediately for this problem. So the next thing you should try is going to be to factor or reduce. Now, can you factor or reduce in this case? And the answer is not really. Your power that your x is to the power of is less than 2, which means you can't really split it into 2 or more brackets that have to be multiplied by each other. However, you do notice that there's a fraction here and a fraction here. So maybe we can try expanding this fraction here and then use the property that if we have something like x over y all over z, that's the same as saying x over y divided by z, which is the same as x over y multiplied by 1 over z, right? Because you can picture the z is over 1 here, and you just flip the numerator and denominator and you switch it to a multiplication symbol. So let's go ahead and try that strategy. So once again, the overall goal here is to change the denominator, that way we're no longer dividing by 0. So how are we going to do this? So let's expand 2 plus 10 over x minus 3. Let's put 2 under the same denominator as the 10 here. So how is that going to work? Well, we're going to multiply the top and bottom by 1, right? Multiplying 2 by 1 isn't going to change 2. However, we're not going to multiply it directly by 1. We're going to multiply it by x minus 3 over x minus 3, right? Because this is the same as saying 1. But when we do this, we can put 2 under the same denominator as 10 and merge those into a nicer fraction. Okay, next thing we can do is probably expand this here, which would look something like this. Okay, fantastic. Now we probably want to simplify minus 6 plus 10 to just be plus 4. Like so, and notice we can factor out a 2 here because 2x plus 4 both share a multiple of 2, or are both multiples of 2. So why would I stop here? Well, what I'm looking to get out of all of this is to really get x plus 2 in the numerator and denominator to hopefully get them to cancel to change our denominator. And that's what I did here. I was able to get x plus 2. So what's left? Well, what's left to do is to use that property I showed you earlier where x over y all over z is really like pretending z is over 1, right? And then saying, well, that's x over y is divided by z over 1 is equal to x over y multiplied by 1 over z. This is exactly what we are about to use here. So let's rearrange this to look like that. Like this, and I put some brackets over x plus 2, so it's a little more obvious for you to see that when we multiply these two together, the x plus 2 down here and the x plus 2 up here cancel each other out, leaving us with this function. Now in this function, if we plug in x is equal to -2, are we going to be dividing by 0? And the answer is no, because when we say, okay, well, as the limit as x approaches -2, that's the same as just seeing what happens when x is at -2. So we're going to get 2 over -2 minus 3, which is equal to 2 over -5, which is really equal to 0.4, or -0.4. And the key note here is this function and this function are both identical. We didn't break any laws here. All we did is multiply 2 by 1 to simplify this, and all we did was just some simplification. That's all we really did here. So there we go, we have solved this limit.